Sie haben jetzt schon unseren Jingle gehört und ein herzliches Grüß Gott Ihnen allen miteinander hier im Heilig-Geist-Spital. Sie sehen schon, der AACII braucht ein kleines Warm-up, das heißt, wir sitzen heute zusammen und unterhalten uns, tauschen uns aus. Nicht nur in deutscher Sprache, wir haben einen wunderbaren Gast aus dem Heiligen Land, Monsieur Olivier Krawicki, Paris Space Week. Grüße Sie, einen herzlichen Applaus für Sie. Neben ihm sitzt Professor Schilling von der Universität Würzburg.
Guten Tag.
Alles, was Bildung ist wichtig und es ist auch ein Start-up neben Ihnen, das ist Synergien IT Aviation aus München. Herr Herze. Unsere Nachwuchsstars brauchen immer die beste Begleitung, eine Guidance. Wir nehmen Guidance, the Deserve Guidance. Und das ist Herr Herwanger mit dem Willstätter Gymnasium und alle vom Willstätter Gymnasium. Wer aufsteht?
Für Nachwuchs.
Ich schaue jetzt gerade in die Richtung IT zum Herrn Ludwig. Sie werden Herrn Ludwig noch hören am Mittwochabend im Flughafen um 8 Uhr zum Thema Cyber Security in Aviation. Und Sie werden ihn auch nicht übersehen. Er ist am Dienstag am Eingang von der Meistersingerhalle, der Hall of Champions. Auf der rechten Seite hat einen großen Tesla und manches verbindet ihn auch mit Tesla. Ein herzliches Grüß Gott mit der Familie und dem Astro-Kosmonauten. Wo Mitarbeiter gesucht werden, war der Herr Marz immer in der Nähe. Deswegen war der Personalchefvorstand von fast allen großen Firmen, die mir jetzt in Nürnberg so einfallen. Deswegen begrüßen wir ihn ganz herzlich. Herr Marz, grüße Sie. She's specialized in our camera team and everything else. And Mr. Haupt, he just reached us from Finland a few months ago. He originates from here, and we're so happy that he found out how to use the sound, how to apply it, right? And Mr. Shalit, he's been around the world in China, and finally he always returns to this place. Isn't it the best place in the world?
It is.
Maybe. Okay. So, very happy to see Ms. Karen Köster at the entry. She's always smiling, and she's the most perfect person. Next to her is IT, Mr. Hemphley. Whenever we have trouble, he finds a solution. So, thank you everybody for coming. And enjoy, please, and talk on your tables, on your theme tables. My husband also enjoys, and we are so happy that he helped us to show on our cars the AACII Congress, and I hope you will have a look at that. Whenever there is Tuesday, we all get prepared for that. So this is a warm meet and greet day, afternoon, enjoy it, and 5:30, 6 o'clock, we move to the other place. Thank you very much for listening. Wir haben hier ein sehr gemütliches Lokal, ein bisschen nürnbergerisch, ein bisschen fränkisch angehaucht, und wir sind mitten in der Stadt von Nürnberg. Die Stadt, die sagt, sie ist ein Technologie-Hub, schon immer gewesen. Franken sind sehr stolz auf das, was sie haben, und deswegen stellen wir Ihnen heute einiges an neuen Technologien vor, und dazu gehört zum Beispiel die Firma Synergien, die aus München gekommen ist, und der Herr Harzer, der uns mit den neuen Technologien vertraut macht. Er hat ganz interessante Dinge zu beschreiben, und wie er es beschreibt, das ist die Überraschung. Wir haben auch den Präsidenten des Marketing Club hier, das ist Herr Peter Hache, der uns wohl bekannt ist, der in seiner Sprache sehr edel und sehr gut spricht, und er wird uns sagen, wie Marketing geht und das anhand des AACII-Kongresses. Da können wir dazulernen. Dann haben wir aus Südamerika nach Deutschland eingewandert, den Herrn Enrique Perez. Arriba, arriba! Er ist ein gelernter Banker und er hat uns gesagt, das MIT in Boston, Massachusetts, ich jetzt auch ein bisschen, hat ihm gut gefallen. Er war in den USA miteinander hier in der schönen Meistersingerhalle. A warm welcome to everybody coming from far and near to this beautiful Hall of Champions. Kleine Technikpause. Okay, I'm extremely grateful that so many of you attend. Wonderful supporters, exhibitors, speakers, jury, fellows, and friends join this aviation, aerospace, Congress, international and interdisciplinary here in Nürnberg. What is the message of this Congress? Hope and courage. Together for a better world. Ein herzliches Grüß Gott Ihnen allen miteinander. Warm welcome here in the Emperor's Castle in the Knight Hall. This is a big history we face here, and we have the grand view over the whole city of Nürnberg, the most beautiful city, never forget that. And we had a good time, had a little talks in the inner court, outside, outdoor, and we enjoy the starter here. And after the starter, we have a nice speech by Karl, the Vice President of the Bavarian Parliament. And I want you to give him a big applause, please. Zu Themen, die uns alles sehr interessieren, die deutsche Sprache von Herrn Karl. Ich durfte erleben, dass es einen Frankentag im Landtag, im Bayerischen Landtag gab. Alle waren ganz gebannt, alle Franken waren ganz gebannt, was passiert hier. Und dann kam Herr Völler auf die Bühne, auf das Podium und hat uns einfach ganz natürlich erzählt, was hier alles für Entwicklungen und Erfindungen entstanden sind, hier in der Region. Und da ging ein Ruck durch die Reihen, dass alle Leute, die vorher ganz verhalten waren, plötzlich gesagt haben, was? Das gibt es auch in Franken. Und es sind immer mehr aufgeblüht, immer mehr aufgeblüht. Und ich hoffe, das geht uns auch so. Herr Völler, the floor is yours.
Liebe Präsident Beckstein, meine sehr verehrten Damen und Herren, dass die Erwartungen gut geschaut, die Frau Trump, eigentlich bloß in der Bescheidenheit eines Franken zu entsprechen. Und freue mich, dass ich es darf. Und Sie haben heute schon einen schönen Talk hinter sich, von dem zumindest die Eröffnungsdiskussion unternehmen, hochspannend. Dann bin ich nach München gefahren. 2 Stunden den Landtag führen dürfen heute bei der Debatte zur Regierungserklärung und bin jetzt wieder hochgefahren nach Nürnberg und habe die Freude, dass ich, wie gesagt, vor einer Runde sprechen darf, die mit hoher Kompetenz das Thema sehr intensiv, seit Jahren wahrscheinlich, oder Jahrzehnten sogar schon, begleitet, das uns mit Sicherheit in eine große Zukunft führen wird, das ist der Raumfahrt. Ich bin Jahrgang 1956, war demnach 12 Jahre alt, als im Jahr 1968 das wohl berühmteste Foto der Menschheit geschossen wurde, nämlich am Heiligen Abend, am 24. Dezember des Jahres 1968, als die Raumfahrer gewesen ist, was an diesem Tag gewesen ist. Da war die Apollo 8 in der Umlaufbahn und hat die aufgehende Erde fotografiert, die Astronauten. Das ist dieses ganz berühmte Bild, wo eigentlich die Sicht auf die Erde verändert hat. Und wenn man heute diese ganze Diskussion von Umwelt und Schöpfung und was damit zusammenhängt, vor Augen hat, dann ist dieses Bild eigentlich das, was man am allermeisten irgendwie doch eigentlich berührt. Dieser blaue Planet, der hier aufgeht und für den wir alle Verantwortung haben. Und daher ist, glaube ich, so ein Kongress eher heute einer, der wirklich von großer Verantwortung getragen wird, weil man sich im Weltraum entwickeln wird, wird sich über Jahrhunderte und Jahrtausende, Generationen prägen. Und ich bin seit dieser Zeit wahrscheinlich sind solche Ereignisse in der Kindheit irgendwie schon dann auch fürs Leben etwas prägend. Begeisterter Freund der Raumfahrt, der mir das Museum auch in Feucht angesehen hat, hochinteressant übrigens. Das lohnt sich tatsächlich, da waren so die Ursprünge der Raumfahrt schon erkennbar, bis zu den Kenntnissen, die sie heute ausgetauscht haben. Und ich nehme an, dass der Markt auch in den nächsten 10 Jahren hier ein Vielfaches explodieren wird, weil das die große Zukunft sein wird. Was ich bedauere, wahrscheinlich die meisten hier im Raum, dass es uns nicht mehr vergönnt sein wird, eine Raumfahrt machen zu können. Vielleicht ist der eine oder andere von den Jüngeren hier, der sich auf eine Astronautenausbildung vorbereitet, aber befürchtet von Nürnberg, die UN haben. Das ist nicht so gewohnt, das Wort TUM ist bekannter, das ist die Münchner Technische Universität München. Aber vor 2 Jahren ist Gott sei Dank noch eine dabei und seit Jahrhunderten erstmals wieder eine neue Universität neu gegründet worden. Wir haben sie im Süden Nürnbergs, sie ist gerade in Werden. Ich erwarte mir von dieser Universität für diese Stadt und ihre Region noch sehr viel. Der Präsident war heute da, der ist noch, das Ganze baut sich erst auf. Es wird aber in einigen Jahren wird es ein Faktor werden, den man nicht unterschätzen darf, weil vor allem Disziplinen dort auch gelehrt werden, die mit Sicherheit sehr zukunftsträchtig sind. Das ist, glaube ich, keine Konkurrenz, sondern eine extrem gute Ergänzung in diesem Raum. Und sind wir froh, dass wir diese Universität also auch bekommen und wir damit die Chance haben, dass wir viele Wissenschaftler in Nürnberg holen. Da wird sich doch ziemlich rapide entwickeln. Also die Flächen sind da und Bauen wird begonnen. Und ich nehme an, dass in 3-4 Jahren hier auch schon sichtbare Ergebnisse sein werden. Ich habe mit dem Präsidenten unterhalten, der mir sehr daran gelegen, auch eine enge Zusammenarbeit mit den Unternehmen, mit den Firmen, mit den Verbänden auch hier in der Region, weil das ein Miteinander geschehen kann. Diese Universität ist für mich eine Freude und ich muss eines sagen, als Vizepräsident, man soll nicht so wie logischerweise andere Aufgaben wie im Exekutivbereich, aber ab und zu dürfen was unterschreiben, was der Landtag beschlossen hat. Und ich war wahnsinnig stolz, muss ich auch mal sagen, das war die Sitzungsleitung, als der Bayerische Landtag das Gründungsgesetz beschlossen hat und dann der Unterschrift ist eigentlich jetzt auf den Weg ging. Da war ich froh, weil ich gesagt habe, du kannst eine Unterschrift leisten unter ein Gesetz, das eine Gründung einer Universität schafft, die wahrscheinlich noch Jahrhunderte hier in Nürnberg bestehen wird und die Zukunft beträgt. Meine sehr geehrten Damen und Herren, es gibt noch vieles zu sagen, was hier noch entstehen wird. Wir werden auch die Digitalisierung wird eine entscheidende Komponente auch sein für jede Art von Kommunikation und Mobilität. Elon Musk hat hier auch Maßstäbe gesetzt. Mittlerweile werden Fortbewegungsmittel und die entsprechende Infrastruktur und die Hard- und Software herumgebaut, auch bei uns. So sollen etwa der Flughafen Nürnberg und der Flughafen München in den kommenden Jahren zu Knotenpunkten eines digitalen Netzwerkes regionaler Verbindungen mit schnellen und CO2-emissionsfreien Kleinflugzeugen werden. Auch auf anderen Gebieten steht die Zeit nicht still, wenn es etwa nach den Wissenschaftlern der Universität Würzburg und des biopharmazeutischen Unternehmens bekannten Centales geht, könnte es möglicherweise sogar eine Corona-Impfung zum Schlucken geben. Die Forschung wollen Antigene in einen Kapsel packen. Physiker aus Oberfranken macht eine Entdeckung bei Blutzellen. Dabei liegt der Fokus auf die Trennung zwischen gesunden und kranken Blutzellen. So könnte den fränkischen Wissenschaftlern gemeinsam mit einem internationalen Forscherteam ein weiterer Schritt auch im Kampf gegen Krankheiten wie Malaria, Krebs oder Diabetes gelungen sein. Eine international herausragende Position nimmt natürlich das Zentrum der Bayerischen Medizintechnik ein, das Medical Valley der Region Nürnberg-Erlangen. Hervorgegangen ist es aus den Vereinigten Physikalisch-Mechanischen Werkstätten Rhein-Georg und Schall in Erlangen, Stuttgart. Hier wurden bereits 1896 Röntgenröhren und Röntgenapparate hergestellt. Sowie der Siemens sind über die Jahre eine Fülle mittelständische Hidden Champions getreten. Dazu gehört etwa der Weißendorfer Titan- und Prothesenspezialist Peter Brehm GmbH und der internationale Marktführer der Human Optics AG, Wavelight oder Konstanz, um wenige herausragende Beispiele zu nennen. Die Europäische Raumfahrtorganisation ESA wird künftig intensiv mit dem Würzburger Zentrum für Telematik kooperieren, das auf Minisatelliten spezialisiert ist. Und Hive Systems aus Nürnberg bietet ein umfangreiches Technologie-Serviceangebot rund um den Betrieb autonomer Flugzeuge. Im Mittelpunkt des Unternehmens stehen Herstellung, Betrieb und Vertrieb von Drohnen, Hangars und auch die Weiterentwicklung der Software und Steuerung der Drohnen. Es ließe sich hier noch sehr, sehr viel fortführen und die anwesenden Unternehmer sind ja alle in irgendeiner Weise befasst und eingebunden. Meine sehr verehrten Damen und Herren, ich darf abschließend sagen, dass wir versuchen, von Bayern aus diese Forschungslandschaft zu unterstützen, so gut es nur geht. Nicht nur was jetzt die Eröffnung des Max-Planck-Instituts angeht, für die Physik des Lichts 60 Millionen investiert. Wir werden in Zukunft weiter investieren. 700 Millionen Euro stehen bei Bavaria One für Zukunftstechnologie im Bereich der Luft- und Raumfahrt zur Verfügung. In der Hightech-Agenda Bayern, in der Hightech-Agenda Plus sind es nun 3,5 Milliarden Euro. Das ist eine bundesweit einzigartige Technologieoffensive mit 1000 neuen Professuren, 13.000 neuen Studienplätzen und mehr als 20 Spitzenforschungszentren. Ja, meine sehr verehrten Damen und Herren, in Franken dürfte das auch besonders fruchtbar am Boden fallen, denn hier, speziell auch beim Europäischen Aerospace-Kongress, wird sehr viel Wert auf Kooperation, Kommunikation und Einbindung beteiligt gelegt. Mit dabei sind große und mittlere Start-up-Unternehmen, Hochschulen, Wirtschaft, Verbände, Studierende und Lehrende und nicht zuletzt auch inspirierte Schülerinnen und Schüler. Deshalb wage ich zum Schluss eine Prognose. Die Metropolregion Nürnberg wird ein starkes Herz in der Mitte Europas und ein Kraftwerk für Ideen bleiben. Sie wird auch in Zukunft für Vielfalt, Forschergeist und Weltoffenheit stehen und der Aviation Aerospace Kongress ist das beste Beispiel dafür. Ich möchte mich bedanken bei allen, die hier mitgewirkt haben. Und ich möchte mich vor allem auch noch bedanken mit einem Blumenstrauß symbolisch bei jemandem, der das Ganze in die Hand genommen hat, und zwar schon seit 1,5 Jahren in die Hand genommen hat, bestens vorbereitet hat. Liebe Frau, der Beifall gehört Ihnen.
Vielen herzlichen Dank für diesen wunderschönen Blumenstrauß, der einen Ehrenplatz erhalten wird. Und ich glaube, er gehört eigentlich nur ein bisschen mir. Aber die meisten dieser Blumen von diesem Blumenstrauß gehören einem wunderbaren Team, das wir hier zusammen haben. Ich habe sie mir heute Morgen schon vorgestellt und ich glaube, wir stellen das ins Büro und alle haben was davon. Ich bedanke mich vor allem bei Ihnen, dass Sie das möglich gemacht haben, dass der AACII-Kongress hier erstmal in Nürnberg sein dürfte. Schauen wir mal, wie es sich ergibt, um Innovationen weiter zu fördern aus diesem Kreis, was es für Fortsetzungen gibt. Vielen Dank Ihnen. dass jeder Bewerber hat sich auf äußerste angestrengt bei diesem Wettbewerb als Kandidat. Und auch denen möchten wir einen weiteren Ansporn und eine Würdigung für ihre Leistung geben. Und darum ist auch die Überreichung an die Kandidaten, an die Bewerber mit einer kleinen Portfolio. Wenn Sie den Namen? Das ist Herr Florian Hilbert. Für ein ganz besonders großes Engagement möchten wir uns bedanken mit einem Pokal an Professor Klaus Böckenwasser.
Nürnberg dann keinen ausgerichtet und zu mehr freue ich mich jetzt, dass wir heute beisammen sind und ich gegeben habe. Herzlichen Dank.
Die wesentlichen Contributions, die ich hatte, war, dass ich auf die Idee kam, dass ich einen Preis her muss für so ein Ereignis und so die Preisträger, die das sehr verdient haben und die sich beworben haben, die direkt ein bisschen was auf meine Idee. Denn das habe ich in den Business gelernt. So eine kleine Auszeichnung, so eine große Auszeichnung ist für die, die schon promoviert sind, und für die, die sich dahin entwickeln, an anderes. Ich glaube, das wird immer gerne gezeigt und Sie teilen das sicherlich auch mit Ihren Mitarbeiterinnen und Mitarbeitern, weil Sie dazu auch was beigetragen haben. Also von meiner Seite einen herzlichen Glückwunsch. Das hat sich gelohnt.
Ich habe als Innenminister und Ministerpräsident hier quasi als Hausherr auf der staatlichen Burg war, als Hausherr dem ersten Vizepräsidenten des Landtags eine Urkunde zu geben, mich dafür zu bedanken, dass er eine Rede gehalten hat, die auch die anwesenden Repräsentanten der Region Württemberg, Kempf, Balleis, Matschl an die Geschichte erinnert hat und dass er die Innovationen des AACII-Kongresses in eine Beziehung mit den großen weltverändernden Innovationen gestellt hat, die aus der Region kommen. Du kriegst hiermit diese Urkunde, aber nur unter der Bedingung, dass du sie in München aufhängst, sodass jeder Besucher sieht, dass Frau Trapp einen tollen Kongress organisiert hat, der eine große Bedeutung für ganz Bayern hat und dass jeder auch sieht, dass dieser AACII-Kongress etwas war, was wirklich auf äußerst hohem Niveau gewesen ist. Ich habe mich heute früh selber davon überzeugt. Dazu diese Urkunde. Herzlichen Glückwunsch dazu.
Und auf die Luft geht frisch und rein, wer lange gesetzt muss rosten, gegen alle Fronten Sonnenschein, das muss den Himmel kosten. Jetzt ein Schlaf, morgen sagt der Fahren so hart, ihr Sommer sein.
Qualität. Und wenn wir uns jetzt hier in diesem Raum umschauen, dann sehen wir langsam den Sonnenuntergang und bald können wir genießen, wenn ein Flieger kommt oder abfliegt. Und gerade war der Flieger aus dem Hause Turkish Airlines, der sich hier fortbewegt hat. Wir haben noch mal überlegt, könnten wir einsteigen, könnten uns die schöne Stadt Istanbul anschauen. Viele Gedanken gehen einem durch den Kopf und deswegen haben wir heute 13. Station. Wenn Sie sich das vorstellen, ist es ein Luft- und Raumfahrtkongress mit 13 Stationen, die wir heute abschließen, hier am Flughafen. Und es ist auch denke ich, ein sehr guter Abschluss für den ganzen Kongress, der den Gedanken hat, auch etwas, die einzelnen Schätze, die wir hier in der Region haben, etwas zu zeigen. Und nicht nur das, sondern dass wir auch Inspirationen, Impulse und Ideen mitnehmen, Anregungen mitnehmen. Und damit wir Anregungen auch nachhaltig und längerfristig haben, sind die Themen auch nicht ganz oberflächlich, sondern in der Technik auch auf die Zukunft gerichtet.
Dear guests, ladies and gentlemen, welcome to Airport Nürnberg. Hoş geldiniz, iyi akşamlar in Turkish. My name is Sümeyye Ay. I am Marketing Manager for Turkish Airlines in Nürnberg. Before starting my presentation, I would like to say a big thank to Ms. Trapp for this great organization and Mr. Paul Söllner from Mittelstand, Bundesverband Mittelständische Wirtschaft, our premium partner. He is unfortunately not here. He stays at home due to COVID in quarantine. But our thank to him. He offered us, he's our premium partner, BFIA. He offered us to attend this great organization. Thank you so much. And guten Appetit. To my presentation now, I will present you, as usual, Turkish Airlines and our main hub, Istanbul Airport, and our sustainability measures. Turkish Airlines is the flag carrier of Turkey and established in 1933 and Star Alliance member and one of the fastest growing airline in Europe also. And in terms of destination countries Turkish Airlines fly, we are number 1 in the world. And we fly 329 destinations in 128 countries. These numbers are always updated because of that I need to look. And we have in our fleet 372 aircrafts within 30 aircraft types. Here in numbers, destination numbers, as you see, we are in Europe very strong. We fly to 116 destinations in Europe. And the last destinations we opened is in USA, Seattle. And from Istanbul, we have daily more than 1,300 flights to all over the world that I mentioned, 329 destinations. So, thanks to our geographical position, Turkey, Istanbul, we can also connect people less than 3 hours to more than 80 destinations in 37 countries. So, in our young fleet, 8.3 average year, we have 372 aircrafts. This is updated with our new orders in April this year. Our target is to reach 400 aircrafts. So, some pictures from our here you see our wide-body aircraft, as you see in business class for long-haul destinations flights, Boeing 777. We have full flat seats opportunity and in-flight entertainments, which makes your flight more enjoyable and a dreamliner picture, as you see. Is anyone here which flies with Turkish Airlines flown?
Yes, me.
Okay. Some information, I think it is not new for you. So, also economy class seats offer a comfortable, relaxing travel experience to you. And thank you for taking picture, but you can also continue with your interview. Thank you so much. I would like to thank you. In economy class also, with our wide leg room, 79 centimeter, we offer also comfortable flights, and in-flight entertainment also is the same like in business class. So, due to sustainable measures, we also don't have any more Skylife magazine by our flights. But because of that, we offer to our passengers who flies with Turkish Airlines a press reader. You can also download it to your smartphone free of charge, and you have variously articles and in many languages that you can also benefit from that. In 2020 and also this year, we have been awarded by Airline Passenger Association, Experience Association as 5-star global airline. And we have been accoladed for our service qualities and on-board and on-the-ground catering and business class and our business lounge. So some of our other awards: Best Corporate Traveler Program, Best Airline for Business Travelers, Best Airport Staff, and many others. Now to my second topic, and my second question: who has been by our new airport Istanbul? Because it has been, it was established in 2019. You have been, Mr. Okay. The first phase of Airport Istanbul is completed with 3 runways and 90 million passenger capacity. When the whole project is completed, we will have 6 runways. It means 6 startup from at the same time, and with more than 150 million passenger capacity. And some figures to Istanbul Airport: more than 500 check-in points and 80% bridge boarding, 143 boarding bridges, and many other features. And the most important features of Istanbul Airport: it is the largest airport under one roof. It means if you have transit flight, you don't need to change your terminal to reach your next gate for your beyond flight. As you see, some our success: Turkish Airlines, #1 airline that flies to highest number of international destinations from a single hub, and many others. By reaching those success, of course, our new airport Istanbul takes a big role. Terminal entrance from Istanbul Airport, some views that I would like to show you. Check-in area and our lounges, which has been awarded by Apex. We have 2 lounges. First of all, Mice and Smice lounges for economy traveler miles and smiles frequent flyer cards of Turkish Airlines. And the same architectural similar lounge is business lounge, is for business class passengers of Turkish Airlines and Star Alliance members due to our agreements to Star Alliance. A view from our lounge, and who has been by our lounge in Istanbul? Have you been, Mr. Gülbek?
The older one, that means 2,000 miles. In the plane to Istanbul, from there with the Ukrainian to Ukraine. So.
Okay. Mm-hmm. And you had 2 hours, I think 1 hour for your flight.
Not
and
even 1 hour. It was less than 1 hour. I was in a hurry.
Okay. No time for lunch. Okay. Now to our sustainability measures, Turkish Airlines. Turkish Airlines attaches a great importance to sustainability. We started this year as of 1st February by our Paris flights with biofuel, which is produced from sustainable sources. We are working with zero waste policy. Between the years 2008 and 2020, 2 million carbon dioxide tons have been avoided thanks to our sustainability measures. Of course, as the airline that flies to more countries than any other airline, we see sustainability as one of our focus points by our growing strategy. And to avoid, of course, noise management and more sustainability, biofuels, we have ordered so many new engine option aircrafts by our for our fleet. And here I show you again the same slide to our fleet. We have one of the youngest fleets in Europe. Young fleet means more sustainability, less noise, and reducing carbon emission. And last but not least, additional to my presentation, here is our awards from 2020. Also, this year we have received from World Finance this year's Sustainability Award, and we have been awarded as the most sustainable flag carrier airline. That's all to my presentation. Thank you for your attention. As a gift, a small our aircraft.
Oh.
It's a small Boeing 777. Thank you so much, Mr. for this great organization.
Okay, one short question. Is anyone from the airport in Nürnberg also here today?
Not today,
Not
because
today.
there's another.
I hope the Istanbul airport is as safe as the Nürnberg airport. I just realized seconds ago my phone was now sitting for 2 hours at my handlebar of my bike outside. It still was there. I just went out. So you can leave your stuff around. Quite safe place. That's very nice. There's an aircraft about to start. Okay, I have to wait 10 seconds.
10 seconds.
But only if we do a laola.
4 seconds. 3 seconds.
Count down.
2 seconds. 1 second. Half a second.
I think that's British Airways.
It's British Airways. No, we don't have Bluetooth on the British.
Yes, see?
Oh yeah, there it goes. Okay, so also hello from my side again. That's my second talk, but I need to do a short recap. Also for the ones that haven't been here for my first talk. The last time I finished with an outlook about really large electric drives, and this is where I want to continue. As a reminder, we are a research institute out of the Fraunhofer Society, and we are focusing on power electronics. Sounds a little bit abstract, but power electronics are everywhere where you need to transfer energy. For example, if you have a battery and you want to turn a motor, battery has DC current, motor needs AC current, power electronics will solve the job. We are a little bit unusual among the Fraunhofer institutes. We are very vertically integrated. We can do everything related to power electronics. Typically you have an institute that's very horizontally integrated, so they have one specific technology, for example some coating technology, and then they use this coating technology for a lot of applications, for sunglasses, laser optics, whatsoever. We are a little bit different there in the Fraunhofer Society. We do everything for power electronics vertically, starting from materials, that's where we are really growing silicon crystals, technologies for cutting wafers like where computer chips are made out of. Then out of these high power chips we create devices and modules that are the basis for power electronics. Then with this we create vehicle electronics and energy electronics. Why is this relevant? This is relevant because we need the whole set of technologies throughout the whole technology chain at the moment to create a leap forward in technology for power electronics. And actually this is happening at the time. Last time I told you things get smaller and smaller. And to recap this, a short video, just as a refresher. Let's see if it works.
Our roads has doubled, and air traffic has risen by a factor. The coronavirus may have slowed things down in recent times, but the pace of life increases nonetheless. Over the last 30 years, the volume of freight traffic on our roads has doubled, and air traffic has risen by a factor of 4. Along with the electric motor, hydrogen-powered drive systems could offer the key to zero-emissions mobility, particularly for long-distance transport. Motorsport is showing how this can be done.
When we combine oxygen with hydrogen, we create electricity and water. And we have a lot of electricity with this process. If you want to move a load like a truck, the hydrogen is the only solution that we have right now.
Sustainable freight transport powered by hydrogen. This is a solution that could soon be racing ahead, thanks to 2 researchers from the Fraunhofer Institute for Integrated Systems and Device Technology, IISB, and their new generation of DC-DC converters.
Our DC-DC converter is a vital component for the use of fuel cells to power future vehicles. In developing the converter, our aim was to substantially reduce its size while also making it more efficient.
The new converter regulates the voltage coming from the fuel cell at an efficiency of 99%. While rival equipment could weigh more than 100 kilograms, the DC-DC converter from Fraunhofer IISB is a genuine lightweight and a mere 17 kilograms. As such, the researchers have turned conventional wisdom on its head.
We've devised a switching technology that produces extremely low switching losses. Contrary to received opinion, we've therefore been able to build a converter that is very small, compact, and extremely efficient.
To understand the increase in power density achieved by the researchers, imagine a power plant compressed to the size of a family home, while still delivering the same amount of power. This required further innovations.
This not only involved new components for power semiconductor devices, it also required new switching technologies that prevent overvoltages during switching and thereby achieve further significant reductions in switching losses.
The converter has already proved itself in endurance tests, including on the racetrack, over a period of 24 hours.
Le Mans is very important for new technologies because it's where we test those technology across race cars, and at the end we use those type of technology on road cars.
In the coming years, this new development from Fraunhofer IISB will pave the way for sustainable mobility on all levels, not only on the racetrack, but also for freight and long-distance transport. This way, we can achieve zero-emissions transport by 2030, on the road and in the air.
Yes, so basically, a recap from what I said last time, how electronics are getting smaller and smaller. And
The coronavirus may have...
And now, new applications are possible. So, over the last few days, you might have realized that I'm a little bit, the exotic guy among all the others, the electric freak. For example. Also another name there. I will have this for a long time. And for what I want to show you now, so here, okay, it's exotic that we want to go to hybrid electric aircraft, but among the hybrid electric aircraft community, we are quite sure that we will, in the next few years, reach power levels of single-digit megawatt drivetrains. And single-digit megawatt, so 1, 2, 3 megawatt of power available to the aircraft will enable small aircraft. Everything that's regional, let's say, inner country flights. But within the hybrid electric aircraft community, also there I'm a little bit the freak. That's the common perception, because I can say we already now can go much bigger. And the slides that I will use here, they are from a power electronics conference. There are a lot of graphs and stuff, don't be lost there. I will use them to explain to you what types of technologies are necessary, and I think then you will get a feeling how broad and interdisciplinary the approach is necessary that we have to go now. Recap, last recap, then we start. The energy distribution in new hybrid electric and fuel cell-based aircraft will be roughly like this. It's an abstract view. On the top you have your fuel cell that's generating your power. Then you have these orange lines, like in the electric car, the high voltage orange cables that distribute the voltage throughout your system. And then in the end you have the drive inverters and the electric propulsion. These are electric motors, like in an electric car, but much bigger. Okay, my question that I was asking in this conference is, how much power can we do? Can we reach 10 megawatts? It's necessary to also go for long distance flights. And so we did an internal study, and as an example, we took a quite big power plant. That's the power plant of an A400M, the military aircraft, and that's quite well known. It has a power of close to 10 megawatts, it's 9 megawatts of power, of course with kerosene driven. And as a feasibility study, we checked if it's possible to build an electric drive system that will fit into this assembly, so we can replace this really huge power plant. And the electric motor design was one part, and the electric power electronics design was the other part. So if we want to drive an electric motor with 10 megawatts, that's definitively possible. There are oil rigs out there that have 10 megawatt electric drive systems. But the inverter systems, they typically look something like this. They are huge racks. For example, this here in the top is from our energy electronics department, and you can see it's really large. It fills half of this room. Actually, it's the smallest 10 megawatt multi-level inverter system for stationary applications that you will find out there, but still it's half the size of this room. And you can imagine, okay, this will never fit. So we need completely different approaches. And we came up with a completely different approaches. We utilized all that we have learned from highly integrated automotive applications and race car applications, and now scaled it up. What do you need to do something like this? We will have this picture in the very end. but it's quite complex, unfortunately. And to build this really huge system, we now have to start very, very small. Imagine power electronics as a bunch of components that you need to combine together. You have power electronic modules and, for example, DC link capacitors. And up to now, it was an easy task to build power electronics. Over the last 20 to 50 years, power electronics engineers, they bought power modules, they bought DC link capacitors, they nicely fit together, they screwed them with bolts, and everything works nicely. Unfortunately, this is how it was done so far. Now we have new devices that are inside these power electronic systems. They came from this semiconductor device technology. They enable what we have seen before, shrinking the size of a power plant to a house. And they have a special, their specialties that they can switch very, very fast. And this very fast switching creates effects that haven't been there before the current was just going from the one to the other device. Now we are switching so fast that even the current that's traveling at the speed of light needs time to pass through these systems because there is some electromagnetic force that counteracts this, and you don't have just the current flowing through your system. You nearly need to analyze exactly how your current is flowing. And so you can't use standard power electronic components anymore. So every power electronic engineer that's out there and very experienced for the last 20 years, unfortunately, is not able to design these new types of power electronic systems. That's what's quite tricky at the moment. We need new engineers that are specifically trained for these new types of power electronic systems. So how do you do this? So this is one of these graphs. What you can see on first sight, there's a red line that does a lot of bouncy stuff. You don't want to have this. Unfortunately, if you just take these new semiconductors that we now have developed and put them in these power electronic modules, give this a standard power electronic engineer, the red line is what will happen. Your system will not work properly. So we need to come up with new designs of these power electronics that it looks like the green line or the blue line, just a little bit of the spring and then everything is fine. How do you do this? Power electronic modules cannot look the same as they have looked so far. We have seen before this box with nice screw terminals, easy to assemble. We need to completely withdraw this solution. It's a completely new approach necessary for power electronic modules. This is a very, very small copper power electronic modules that's just like this size, and that's the same like a power electronic module this size before. It extremely reduces your size. Unfortunately, now you need new interconnection technologies. Before you can screw it together, now you need laser sintering and new interconnection technologies, and you even need to stack single devices that have before been placed beside each other, above each other. And if you give this to the old world of power electronics design, they will freak out, crawl below the table and hold tight to their rulers. Because this is really difficult to do, but it's possible with new technologies. What else is necessary? Maybe you remember this aircraft from a first presentation where I've showed you that it's possible to integrate motor and inverter into this white, nice electric propeller design. Usually, power electronics are boxes that are placed somewhere in your vehicle. Then you take cables and connect it to your motor. This is of course easy because one can take care of the power electronic box, the other one can take care of the electric motor, and then you have your cables. Unfortunately, this costs a lot of weight. You can imagine cables, housings, all the sealing, connectors, all the weight that we don't want because we want to have the light systems. So we need super tight integration of the power electronic that sits here in this nose cone right together with the electric motor that's in front of the propeller. And now you see, if you need this super tight integration, you can't train like an electric engineer that is trained to build on PCBs. PCBs are these green plates with all the components. Typically they're just stacked and then there's a box around them. This can't be done anymore. You need to integrate everything 3D geometrically inside your system So you need a deep collaboration of mechanic design and electric design. So you need mechatronic engineers that also solve the thermal issue of your system. But if you do this, it's possible. So deep mechatronic integration is necessary. This is just another example of deep mechatronic integration. You see how it looks like in this cross-section. You have the electric motor and the power electronics within the same housing. This is really, some years ago, this was not to think about even. Now we solve this issue of deep mechatronic integration. Trained new power electronic engineers can do this. And if you do this deep integration, there's one big advantage that enables another technology that's necessary. I said before, we have a box. Let's say the red part here is the box, the round thing is your motor, and the colored lines, these are your cables. You can imagine if you have a lot of cables, you have a lot of weight. So in the standard design, you cannot use more than 3 cables. Each electric motor typically has 3 cables. Unfortunately, if one of the 3 cables breaks, your motor will break. It's not possible to run a standard motor with 2 of these 3 cables. Would be nice. So we design motors with redundant cabling. And you can easily imagine if I now have, instead of 3, 6 cables, 9 cables, 12 cables, the weight would explode. But with the deep mechatronic integration, we can do this. We get rid of all the cables and still can have these 1, 2, 3, 4, 5 as multiple subsystems integrated to one system. And if you now lose one subsystem, the rest can still turn the motor. So you gain safety. Now you might say, okay, if I do this, that I have this multi-redundant system with all the single subsystems, this sounds super complex and I need a lot of individual components in there. For sure, this must increase the weight of my systems. At least that's what the perception typically is. No, turns out it's exactly the opposite if you design your system right. For example, at the top, the right round part is your electric motor. This lot of lines is your power electronic systems, and these are your power modules. And it's a little bit abstract for a power module, but think of this as one power electronic module. And if you now count the number of power electronic modules necessary, it's the same for the 3-phase system than for the 6-phase system. It's exactly the same, so the weight will stay the same. But now I have the 2 separated systems, and if one fails, the other can still turn. So no weight increase. The crazy thing is, even a weight decrease will happen. How is this possible? This is possible if you look at the picture at the top side. There is a special electric part that's called gate driver. It's the blue box. And the blue box has to take care of all the power electronics modules that are connected side to side. And if you do this connection with 2 power electronic modules, there is a long red line from this blue gate driver box to each of the modules. Unfortunately, the longer this red line, the inefficient your system is, so you lose efficiency. Now if we do this, no weight increase here, but efficiency increase here. Totally crazy. I reduce this red line here. I increase the efficiency, so there is less thermal losses are produced. So imagine if you have 98% efficiency and you now increase this to 99% efficiency, you might think, why would you do all this effort? It's already super efficient. This 1%, does this really give a big deal? Think of the cooling system. You need to take this heat load and take it out of your system. Before you have 2% losses, let's say these are 2 kilowatts. Now I go from 98 to 99. I only have 1 kilowatt of thermal losses. I cut my cooling system in half, and the cooling system is typically a super heavy system inside your overall aircraft. So you gain actually a lot of weight by going from the 3-phase to the 6-phase design. And does not stop there. This now really goes deep in power electronic design, but the crazy part is you have seen before you need this power modules, what we talked about before, and you also need this capacitor, you need to connect them. If you do this with the 6-phase approach and then do some software magic, you can reduce the size of this DC link capacitor also. And all these effects together make, even if your system looks more complicated, actually it reduces to a much more lightweight system. And then there's more. This was on the power electronic system. Now, if you look at your electric motor, also your electric motor has a certain efficiency. You put some current in and it turns, but it's not perfect, so the motor will get hot and you need to recool it. This is a function of how good your power electronic system is. Think of like the current that goes out of the socket at the household. It's 230 volt AC current. Everyone has heard this before, it's on each of these connectors, on each charger, 230 volt DC. So an AC means it's a sine wave of current. Looks like this. And your motor is working very efficient if you have this kind of sine wave. Unfortunately, power electronic systems, I really love power electronic systems, but they do also a lot of mess. And one of the mess power electronic systems are producing is that the sine wave does not look perfect. You see it on the top side, there's a lot of ripple going on, and this reduces the efficiency of your electric motor. If you now go to a multi-phase approach, so this is a little bit more complicated multi-phase approach, but think of the same like what I said before. Your sine wave will get more smooth and you reduce the losses inside your electric motor. So also the cooling system of the electric motor. You can do some more software magic, so you can easily imagine it's just zoomed in. Yeah, that's not looking nice. You easily can see, okay, you want to go from this to that, so you need to increase this switching frequency. That's just one of these values where we characterize how good something is working. You need to increase this. To do this, you need again these new devices that we have talked before, so really the new materials, then you can do this. You can increase your efficiency. If you do this, you increase from the blue line to the red line your efficiency, but there's a catch. This is for all the students, especially if you want to do some calculations on electric motor systems. There is one, there's a trap. The trap is, if you calculate the efficiency of your electric motor, the dot up there is what all your calculation programs will tell you how efficient your electric motor is. Unfortunately, even if you do the best power electronics, reality never is perfect. Your real efficiency is reduced. And you need to understand exactly how much this deviation of what is written in the textbooks and what will be in reality is necessary. And to do this, we need to enter a new field that's necessary for this interdisciplinary approach, and that's the simulation. And with simulation tools, you can now exactly define, okay, what is the final efficiency of your motor? Because you can imagine designing your cooling system too big or too small is really an issue. And if your motor is not that efficient, your cooling system is too small, everything will get hot, you will lose efficiency again. Okay, and if you do this, how does these new power electronic engineers now design one of these 10 megawatt systems? Now we've seen all the technologies necessary that we bring together. It's just a quick walkthrough how a power electronic engineer works. Unfortunately, there's not one solution that you can just walk through and then you will get your system. The bad thing in power electronics is you want to have one solution and there are a dozen of ways how to achieve the solution. So your power electronic engineers will go through all these decisions, okay, which I use for which topology in the end I will use. After he did this, he needs to calculate, don't read too much, remember, just needs to calculate, okay, which of the devices is generating how much losses, how do they interact with each other. So we then dissect this design in simulation models, use this simulation chain, and when we have done this for the sub-modules, then we integrate them for the overall modules, and now you see what our approach is. We try to use a lot of identical modules and connect them in parallel. So we have again this fail operation, this fail topology. Then back to the simulation again. Now this is more for the electric engineers. You need to simulate the magnetic flux in your electric motor. You need to optimize, okay, how many magnets do I have? Unfortunately, this is, as I said, in power electronics, you have a lot of choices which one to pick. An experienced power electronic engineer can do this by hand. For the motor design, we already left the field where you can cope this with your mind. Yeah, it's just not possible. The possibilities are really endless. So what we developed and what's really improving the overall process is automated algorithms. We feed these algorithms with the whole design parameter, and the computer will find the best design. And it's really that complex that we lost the area where we can find it with our head. But through this optimization process, then we get our power electronics and we get our electric motor. And then this is the result. So after we have done all this, this is now what we are working on. This is now the basis to design a 10 megawatt power electronic systems for 10 megawatt electric motor. And through this feasibility study, we now clearly see that it is already possible with the technology that we have in the lab now. It's not commercially available technology, as you can imagine, so it takes some years now until its power modules are available. But we see there is a clear way even to this multi-megawatt applications. Let's just skip this. But one last thing that I want to stress your mind a little bit more. Now we have this quite complex system. And you have seen it is super complex, and there are a lot of sensors integrated and a lot of software is necessary to control it. Seems like a disadvantage, and there again you need to come up with cool integration solutions, and then you can turn a disadvantage to an advantage. What we do at the moment is, as I said before, you have this sine wave of current that goes into your electric motor. This sine wave is measured by all these current sensors as part of the power electronic systems. And what we now do is we analyze this current exactly in detail. And if a bearing is breaking, the motor is not turning like perfectly a harmonic round again. You can easily imagine, like if your wheel hub is broken and on the bicycle, there's this rattling when you turn the wheel. This rattling causes the current, funny enough, of your power electronic systems to look like this. And then now you can, just from analyzing the current, you can realize, oh, my bearing is breaking. Without any bearing sensor, what you typically would add, what's expensive, what's prone to failure and so on. And this is what we are doing at the moment. Unfortunately, it does not look like this. The first two pictures would be nice. The signal that we are analyzing is looking like this. There's a lot of noise. So again, you can't see it with your eye, but you can train a computer algorithm to dissect all this noise and then analyze, okay, good bearings, broken bearings. Also, the human mind cannot solve this, but now we have computer algorithms that are fast enough to do this, and now we can do online health monitoring of electric motors just with power electronics. That's really totally crazy. No one thought about this just some years ago. Yeah, and now we already detect 100% of broken bearings and a little bit false positive, but work on this over the next years. Last slide. So how will we continue with this process? For sure, this was an outlook far in the future, even for us, that we are really pushing everything to the limit. We are building at the moment an electric drive test bench capable of 1 megawatt, so we will be able to test a system of this at 10% of its power. The great part is we have this multi-level converter system for a stationary application, and we can use this to test the inverter system at 10 megawatt power level. So if we find the financing and research programs to put forward there, we already now have the testing capabilities necessary. Yeah, and with this I want to come to an end. It was a quite deep dive to what is necessary, but I think you have seen how interdisciplinary the approach is necessary. So really this is mainly in the direction of all the new students available here. You have seen, you will find in any field that you are interested in, you will find some specific technologies that will contribute to this. So if you want to go in this field of electric aviation, I highly recommend you because you need sustainable aviation from the long term, you will find something. Even if you think, okay, this is too much off, there is some catch where you will find it. And yeah, the last part is we have heard Turkish Airlines before, and this looks completely different and like two worlds, but you are the ones that in the end want to buy these new aircraft. So I can develop the best technologies. In the end, it has to be a viable business case. So we deliver our technology to the aircraft manufacturers, but in the end, it needs to be competitive enough. So the airlines want to have this, but we have seen before, sustainability is already now a quite huge goal. And with these technology, we think we can go to a full zero-emission aircraft on the long term. And this is the goal, and this is why we are putting a lot of effort in this. Okay, I come to an end. Any questions?
Well, let's give you a nice applause. This was
This is IT security or prevention of cyber risks in field of aviation. So a little bit about my person or our company. I'm pilot myself, so I know about the requirements for aerospace applications, for services applications and so on. And I'm involved in these topics, especially what's all about maintenance, ground service, flight service, flight direction. And there's a lot of IT environment included, a lot of IT equipment.